a world where everyone has access to the best surgeons, literally everyone. And Optimus will have a level of precision that is frankly superhuman, and will be able to do medical procedures, of very sophisticated medical procedures, any medical procedure, perhaps things that really humans can't even do because they're too difficult. And that will be available to.
Elon Musk just made a huge announcement that has everyone talking. He said that Optimus robots will soon be performing surgeries with unbelievable precision. This could change healthcare forever. But what does this really mean for the future of medicine and for all of us? The world is waiting to find out.
The robots will be able to make anyone a house. And, as long as you don't insist on it being in a particular location, you can have robots will be able to build you a castle if you want.
Elon Musk appeared on Barron Capital with analyst Ron Barron, where he outlined his vision for Tesla's Optimus humanoid robot in the medical field. The billionaire entrepreneur made specific claims about the robot's capabilities that extend far beyond current industrial applications. Musk stated that Optimus will achieve a level of surgical precision that surpasses human ability. He described scenarios where the robot performs complex medical procedures that are currently too difficult for human surgeons to execute. The robot's hand dexterity, according to Musk, was specifically designed to enable surgical and precision medical actions. Imagine a world where everyone has access to the best surgeons, literally everyone, Musk said during the interview. And Optimus will have the level of precision that is frankly superhuman and will be able to do medical procedures, very sophisticated medical procedures, any medical procedure, perhaps things that humans can't even do because they're too difficult. The Tesla CEO addressed what he considers a fundamental limitation in healthcare delivery. He pointed to the finite number of highly skilled surgeons and physicians as a bottleneck that money alone cannot solve. Musk argued that exceptional medical professionals do not scale, creating an inherent inequality in healthcare access globally. His proposed solution centers on mass production. Musk stated that while great doctors and surgeons don't grow on trees, Optimus robots will be built in factories, theoretically removing the supply constraint. This manufacturing approach would transform elite surgical care from a scarce resource into an abundant one. The announcement represents Tesla's most ambitious application for Optimus to date. The humanoid robot, which Tesla has been developing for several years, was previously showcased performing tasks like folding laundry, walking, and basic object manipulation. Medical surgery represents a significant leap in complexity and precision requirements. Musk connected this technological capability to broader social goals. He stated that people frequently discuss eliminating poverty and providing universal access to quality medical care, but lack concrete implementation methods. According to Musk, Optimus addresses this gap by making the highest level of medical expertise universally available. The statements come as Tesla continues development of its humanoid robot platform. The company has demonstrated various prototypes at public events, showing incremental improvements in mobility, dexterity, and task execution. Tesla operates a robotics facility where engineers work on advancing the robot's capabilities. Musk's vision for Optimus extends beyond individual patient care. He framed the technology as a solution to systemic healthcare inequality, where geographic location and economic resources currently determine access to specialized medical treatment. By deploying Optimus units globally, Tesla aims to democratize access to expert-level surgical procedures. The precision requirements for medical robotics are substantial. Surgical robots currently in use, such as the Da Vinci surgical system, operate under direct control of trained surgeons. Musk's description suggests Optimus would function with greater autonomy, executing procedures independently while maintaining superhuman precision standards. Tesla's approach to medical robotics differs from existing platforms in its humanoid form factor. Current surgical robots are purpose-built machines designed for specific procedures. Optimus, as a general-purpose humanoid robot, would theoretically adapt to various medical tasks using the same physical platform. The manufacturing scale Musk envisions would require significant production capacity. Tesla currently produces electric vehicles at multiple factories worldwide. Applying similar mass production techniques to humanoid robots presents distinct challenges in terms of complexity and cost structure. Musk positioned this development within his broader competitive strategy. The United States faces increasing competition in robotics development from China and other nations. By advancing Optimus capabilities in high-value applications like surgery, Musk aims to establish American leadership in the humanoid robotics sector. The regulatory pathway for autonomous surgical robots remains undefined. Medical devices require extensive testing and approval from agencies like the FDA before clinical deployment. Autonomous systems performing surgery would face additional scrutiny regarding safety protocols and liability frameworks. Tesla has not released a timeline for when Optimus might begin performing medical procedures. The company continues to refine basic capabilities like walking stability and object manipulation. Achieving surgical-grade precision represents a substantially higher bar than current demonstrated abilities. The interview with Baron Capital marks the first time Musk has publicly emphasized medical applications for Optimus in such detail. Previous statements focused primarily on manufacturing and household tasks. This shift in messaging indicates Tesla's evolving strategy for the robot's commercial deployment. Musk's statement that Optimus will eliminate poverty through universal healthcare access makes a direct causal claim. He argued that limited access to elite medical care contributes to poverty conditions, and removing this bottleneck through robot surgeons addresses root causes. The technical specifications required for surgical precision involve multiple systems working in concert. Visual processing must identify anatomical structures accurately. Haptic feedback systems must provide force sensing during tissue manipulation. Motion control systems must execute movements at sub-millimeter accuracy while compensating for any instability. Tesla's vertical integration approach applies to Optimus development. The company designs its own actuators, sensors, and control systems rather than sourcing components from specialized medical robotics suppliers. This strategy mirrors Tesla's approach to electric vehicle production. Competition in the humanoid robotics space includes companies like Boston Dynamics, Figure AI, and several Chinese manufacturers. Musk's emphasis on American leadership reflects awareness of this competitive landscape. He has previously stated that China is developing humanoid robots at a rapid pace, creating urgency for US advancement. The Baron Capital interview reached audiences across social media platforms, with multiple clips circulating on X. Users shared Musk's statements about superhuman precision and universal access to surgical care. The announcement generated discussion in both robotics and medical communities about feasibility and implementation challenges. In 2025, robots are breaking all the rules. Some robots have started performing kung fu, while one robot has become capable of swapping its battery in 3 minutes, and Neo by 1X is already available to purchase for your home. These are 10 robots that just shocked the internet, and wait until the end, as you will not believe what the top 3 robots can do. Starting at number 10, Northwestern Polytechnical University, in collaboration with KAIST Robotics Lab, unveiled RoboPanOpties in January 2025. According to the RXIV research paper published January 9, 2025, the robot achieved whole-body dexterity through a camera system distributed over its entire surface. RoboPanOpties learns manipulation skills directly from human demonstrations, succeeding in unboxing items in narrow spaces, sweeping oversized objects, and completing multi-step stowing in cluttered environments. A May 4, 2025 update documented continued improvements in adaptability and efficiency. Number 9 takes us to Pudu Robotics, which launched the Pudu MT1 vac on July 15, 2025. This AI-powered robotic sweeper and vacuum integrates sweeping, vacuuming, and dust mopping in a single machine. The industry-first twin-fan design boosts suction efficiency by 200%. The 55-centimeter suction path and 20-liter total capacity support up to 10 consecutive days of operation in 1,000 square-meter carpeted areas. HEPA 11 filtration captures over 98% of 0.3 micrometer particles. Pudu Robotics has shipped over 100,000 units to more than 1,000 cities across 80 countries. At number 8, Northwestern Polytechnical University introduced the Ghost Jellyfish drone in October 2025. Developed by Taokai's team, this transparent underwater robot measures 120 millimeters in diameter and weighs 56 grams. Made from hydrogel electrode material, it consumes only 28.5 milliwatts of power. Daokai stated on October 21 that the robot's characteristics give it advantages in deep-sea monitoring and inspection of underwater facilities. During an August 2025 CCTV demonstration, the robot recognized symbols and clownfish. Number 7 brings Reachy 2 from Pollen Robotics, unveiled at CES 2025 in January. CEO Mathieu Lapierre stated the company offers the only modular, open-source humanoid robotics solution for today's market requirements. With over 100 robots deployed across 20 countries, Reachy 2 runs on ROS2 Foxy and handles 3-kilogram payloads. Customers include Hugging Face, Accenture, Cornell University, and Carnegie Mellon University. Hugging Face acquired Pollen Robotics in April 2025, marking its first hardware sale. Reachy 2 is priced at $70,000. At number 6, Agility Robotics continued testing Digit V2 at Amazon facilities throughout 2025. Standing 5 feet 9 inches tall and weighing 140 pounds, Digit handles 35-pound payloads. April 2025 brought expanded battery options, autonomous docking, and streamlined manufacturing. GeekWire reported on April 1, 2025 that Agility was raising $400 million at a $1.75 billion valuation. The Salem, Oregon RoboFab facility can produce over 10,000 robots yearly. In 2023, Agility partnered with GXO Logistics in the first commercial humanoid robot deployment in logistics. Number 5 showcases Walker S2 from UBTech Robotics, announced in July 2025 as the world's first humanoid robot capable of autonomous battery swapping. A video released July 17, 2025 demonstrated the Walker S2 completing battery swap in 3 minutes without human intervention or shutdown. Standing 160 centimeters tall and weighing 43 kilograms, the robot features dual battery power balancing technology. Each battery provides 2 hours of operation while walking or 4 hours when standing. The robot has 20 degrees of freedom and lifts 15-kilogram payloads, with waist rotation reaching plus or minus 162 degrees. UBTech demonstrated Walker S2 with its BrainNet 2.0 system at Zeekr's 5G-enabled smart factory. NEO, BYD, and Zeekr tested UBTech humanoids on production lines throughout 2024 and 2025. UBTech Robotics listed on the Hong Kong Stock Exchange in December 2023. At number 4, 1X Technologies unveiled Neo Gamma in February 2025, followed by the full Neo launch on October 28, 2025. The Norwegian company developed the first consumer-ready humanoid robot for home use. Neo features a 10 times increase in hardware reliability and operates at 22 decibels. Weighing 66 pounds, it lifts 154 pounds while carrying 55 pounds. Built with 1X's patented tendon drive using the highest torque density motors, Neo features 22 degrees of freedom hands. CEO Bernd Bernage stated in March 2025 the company plans to test Neo Gamma in a few hundred to a few thousand homes by year-end. 1X targets 100,000 units by 2027 and millions in 2028. Backed by OpenAI, Neo is estimated to cost between $20,000 and $30,000. Number 3 introduces Unitree G1, unveiled at ICRA 2024 in May. Standing 127 centimeters tall and weighing 35 to 47 kilograms, the G1 starts at $16,000, a 90% reduction from the H1's $150,000 price. The robot features 23 to 43 degrees of freedom with 120 Newton-meter joint torque and 2 meters per second walking speed. Equipped with Intel RealSense D435 and Livox Mid 360 3D LiDAR, battery life provides 2 hours with quick swap capability. As of 2025, the G1 became the best-selling humanoid robot with over 1,000 units shipped, achieving world records including a 1.4-meter long jump and side flip. Number 2 belongs to Figure 03 from Figure AI, announced on October 9, 2025. The third-generation humanoid robot features a completely redesigned sensory suite and hand system built for Helix, Figure's proprietary vision language action AI. The new camera architecture delivers twice the frame rate, 1/4 the latency, and a 60% wider field of view per camera compared to earlier models. Each hand integrates an embedded palm camera with wide field of view and low latency sensing. New tactile fingertip sensors detect forces as small as 3 grams. The robot features 35 degrees of freedom, including human-like wrists, hands, and fingers. Figure 03 includes wireless inductive charging at 2 kilowatts through coils in the robot's feet, allowing it to step onto a wireless stand and charge automatically. Production takes place at BotQ, Figure's manufacturing facility, initially capable of producing up to 12,000 robots per year, with a target of 100,000 over the next 4 years. In September 2025, Figure AI secured $1 billion in investment at a valuation of $39 billion. The company's investors include Nvidia, Jeff Bezos, OpenAI, and Microsoft. Figure 02 robots have been working daily 10-hour shifts, lifting parts at a BMW factory. Time magazine included Figure 03 on its Best Inventions of 2025 list. At number 1, Tesla Optimus Gen 3 dominates social media discussions and remains the most famous humanoid robot on Earth. First announced at Tesla's August 2021 AI Day event, the project has progressed through multiple generations. The current deployed version is Optimus 2.5, unveiled in September 2025 with a golden exterior finish. During Tesla's Q3 2025 earnings call on October 22, CEO Elon Musk stated that Optimus V3 will probably be unveiled in Q1 2026. Musk described the upcoming generation, saying it won't even seem like a robot and will seem like a person in a robot suit, appearing so real that observers will need to poke it to believe it's actually a robot. The robot measures 5 feet 8 inches tall and weighs 125 pounds, with a carrying capacity of 45 pounds and deadlift capability of 150 pounds. Generation 3 will feature 22 degrees of freedom in the hands, plus 3 in the wrist and forearm. By mid-2025, Tesla had built over 1,000 Optimus prototypes and deployed quite a few of them in battery production workshops. Tesla's first diner in Hollywood opened in July 2025, with Optimus robots serving popcorn to customers and interacting with guests. In June 2025, Milan Kovac, head of the Optimus program since 2022, announced his resignation, with Ashok Eluswamy, head of Tesla Autopilot teams, taking over the role. During the Q3 earnings call, Musk stated plans to produce a legion of 5,000 Optimus units in 2025 for use on Tesla's assembly lines, scaling to 50,000 units in 2026. Target pricing aims for around $20,000, with Musk emphasizing that Optimus will ultimately cost less than a car. In September 2025, Musk publicly stated that 80% of Tesla's future value will come from Optimus and related AI businesses.